Good afternoon, everybody. I think we're going to go ahead and get started. Thank you for joining me this afternoon. My name is Ryan Jones. I'm the Principal PM Manager for the Resource Manager team. Of course, I joke with my colleagues all the time with our new standardized titles at Microsoft. This means I am the Principal Program Manager of Azure Resource Manager. I don't think we have enough managers in that title. So thanks for joining me once again. A couple of housekeeping things before we get started. Through today's session, we do have a couple of demos that will take a little bit of time. And so while those demos are running, we'll take those time for questions. If you can, please use the microphones. If you're not able to, raise your hand and I'll do my best to call on you. I will do my best to repeat the question so that everyone else in the room can hear, as well as so that we'll catch your question in the recording and so that our friends who are streaming can watch it. If I forget, you can all yell out to me in unison, please repeat the question, because I guarantee I will forget to repeat the question. Sound good? Cool. So with that in mind, our agenda for today, and if we go through the agenda and it doesn't sound interesting, feel free to go catch another session. It won't offend me. I want you to get the most out of your Ignite this year. So we're going to talk about how you can automate build and deployment of your ARM templates so that as people check in code, it flows seamlessly into production environments. And so we'll configure continuous deployment using GitHub, Visual Studio Team Services, and ARM templates. The next thing that we're going to talk about is how you can secure your secrets. How many of you guys have been working on an ARM template and accidentally checked a password or a certificate into source control? Okay, thank you for being honest. So we'll show you how to not do that, because there's no better way to spend a weekend than rotating your secrets across your prod deployment because you just put your secrets on GitHub. Haven't lived that before. The next thing is we'll talk about how to govern and protect your assets by using resource policies as well as resource locks. And then we'll wrap up by talking about how to leverage best patterns and practices. We'll cover some of the new template language expressions or functions that we've added since we chatted last year at Ignite. And then we'll have my friend Telmo come up. He works in Azure CAT, the Patterns and Practices team, and he'll walk us through some of the reference architectures and building blocks that they've created to help you build complex application topologies. So sound good? Cool, let's get started. So one of the questions that I asked myself a while back is, why do we have people deploying applications to production? Because let's face it, we're all human, we all make mistakes. Mistakes going against production environments are bad. And so what can we do to decrease the opportunity for human error? And so one of the things that we think is important is setting up continuous deployment. How many of you use continuous deployment with your ARM templates today? Okay, so it'll only be review for maybe 3 of you. For everybody else, this hopefully will be very helpful. A typical continuous deployment pipeline might look something like this. You have a source control repository into which folks, whether they're developers or IT pros, check in the application as well as the ARM templates that describe the app topology. These assets are then built by a build server. They can then be tested. Once a build is ready, they can then be approved and then released or deployed, okay? And so we'll walk through one particular way that we can do this. We'll use GitHub, Visual Studio Team Services, and ARM templates to do that. One thing that's very important to keep in mind as we walk through the demo is think of these different pieces and parts as Legos or building blocks that you can use to build your own continuous delivery pipeline or continuous delivery system. You'll see a number of places throughout the demo where you could mix and match. So if you wanted to use VSTS source control instead of GitHub, you can do that. If you wanted to use Jenkins for orchestrating your deployment workflows, you can do that. If you don't want to use ARM templates, well, I guess you're probably not in the right session. So with that in mind, let's switch to demos. Oh, one other note. All of the demos that we walk through today, the source code is available on GitHub. If you go to RJ Max WAC Ignite US 2016, you'll find all of the scripts and all of the templates that we use throughout our discussions today. And if you have any questions about those, you can either file an issue or you can ping me on Twitter. One important note, if you do ping me on Twitter, I'm actually on parental leave right now. I came here and presented as a favor to my boss and because I wanted to talk with you. So it might be about a month before I get back to you. Okay, I'm back in office October 24th. So I'm going to go to Visual Studio Team Services. I've created a project called Ignite US 2016, and what I'm going to do is create a build definition. Now these build definitions, there are a number of templates from which we can start. I'm a glutton for punishment, and so we'll go with the most complex option. We'll start empty and we'll build from scratch. And then I define the source for my build definition. You'll see that it can come from VSTS source control itself, GitHub, a remote Git repository, or Subversion. I'm going to pick GitHub, and then I'm going to click this checkbox right here, which sets me up for continuous integration, which will cause VSTS to spin a build every time a new change is checked into this GitHub repository. Okay? So I'll click Create. That'll take a few moments. And so now I need to wire up VSTS with my GitHub repository. And so I will need to create a connection. I will need to add a service endpoint, GitHub. I will grant authorization. I will click Authorize. And I will click OK. And so now VSTS knows how to communicate with GitHub. So I'll go back to the original tab. I will refresh here. It sees that new connection that I just created. And now it's going to load all of the repositories that my user has access to. For good or bad, I do work at Microsoft, and so I have access to about 4 million repositories. Okay. So Ignite US 2016, this is a repository that I showed you earlier, that website where all of our source is located for today. I'll pick the default branch, it's master in this case, and then I'll say, yeah, let's do builds clean. And so I will save this, we'll call this Ignite build. Sorry, I'm out of creative names, and click OK. And so now this build definition is set up and wired up to trigger upon every check-in into that GitHub repository. However, it's not going to do very much right now because I don't have any build steps. And so what I'm going to do is I will add a build step. And so what we're going to do here, normally if you had a full application, you would add, MS build or MS build following VS settings, so on and so forth. We're going to keep this simple. We're going to be doing a hello world template, but pretend for a moment that we had a much, much more complex build step happening here. And so what we're going to do is, hey, we have a template. There's not really any build to do. And so really what we want to do is we want to test deploying that template before we publish the build to be consumed in subsequent release steps, okay? And so what I'm going to do is I will select the Azure Resource Group deployment operation, and then I'll click Close. And so we'll see here, I pick a subscription. I haven't yet told VSTS how to communicate with Azure. And so I will need to configure that here. And so I will go to New Service Endpoint. I will select Azure Resource Manager. I will give this a name, and it will enumerate the subscriptions to which my user has access. I'll pick this one right here. And what will happen behind the scenes is VSTS will create a service principal in my AAD tenant, and then it will grant that service principal the contributor permission at subscription scope. So what's happening here is we're using the inbuilt role-based access control functionality of Resource Manager to wire up VSTS and Azure, okay? So I will click the OK button. And so it's going to create, there's actually 3 steps behind the scene that happens. It creates an application, it creates a service principal, then it grants permissions to the service principal. That magic has now happened. And so I will go over here, I will click the refresh button and cross my fingers. And there we have the new subscription. Action will be create or update resource group. I will select a resource group name. We'll go with Ignite CI/CD. That resource group already exists, so location is ignored. Deployment mode is incremental. And then I will pick the template to deploy from the repository. It's right here. In this case, this template doesn't require any parameters. And so I will save the build definition. And now just to get things going, actually, let's do this for real. So let's see where, okay, I'm going to go into this directory. And so you'll see here we have our demo template. So I'll open this up in VS Code. VS Code has support for editing ARM templates. So, our first and best experience for editing templates is, of course, in Visual Studio. We have very rich IntelliSense and wizards for you there. However, if you're looking for an experience that's more like a rich text editor, or if you only work with Resource Manager templates from time to time, VS Code may be a better choice for you. So let's see. Here, instead of hello world, we will say hello Ignite. Creative demo, right? You've never seen anything like that before. And so what I will now do is I will add that change locally. I'll commit the change. Add a comment. And then I will, push this change to GitHub. And so if I go to GitHub and look at the source here, you'll see that 18 seconds ago, I don't think it was that fast. Of course, you see the change happens here. And now if I go over to here, we'll see that I currently have a build in progress. Okay, and we are waiting for an agent to pick up this build. Okay, and so there we go. So it's now pulling the code into this particular machine, and it's going to try to deploy this template. And so think of this going to some sort of testing or validation environment. And so once this is done, we want to publish this build for consumption into a production release. So I'm going to go to the build definition itself. I'm going to edit that build definition. And I'm going to add a build step. And I will select Publish Build Artifacts. And so what this is going to do is each time the build completes or runs, it's going to create a durable archived build that I can use for subsequent releases. This is very important in that if you ever need to deploy an older version of your bits, you will still have them around, okay? And so I will enter the details here, path to publish. I will select this directory here. I will give the artifact a name. Sorry, not very creative today. We'll call it build. And then I will select an artifact type, and I will click save. And so just for giggles, I will go ahead and queue a new build. This is the same thing as if I had checked in another change through Git earlier, okay? And so while this build kicks off, let's work on defining our release workflow. And so imagine that build completes that we just kicked off. It deploys successfully to a testing environment. You could have further automated tests which run against that deployment. We then publish the build artifact to then be used in a subsequent release. And so we're going to now create that release definition. We'll go with empty here. And then our release definition artifact is a build, and it comes from this build definition that we created earlier. And I'm going to click this checkbox here, which says that we'll set up continuous deployment so that we create a release and deploy as soon as a build completes. And so now I will click create. It automatically creates an environment. You can have releases deploy to multiple environments. And I will now add a task. And so this will look very, very similar to what we did in our test deployment step earlier. I'll click add and then close. I will pick my subscription. I will pick my resource group. I will pick the template. oh, our build hasn't completed yet, so I'll have to come back and do that step here in a few moments. But what will happen here is I'll say, hey, this is the path of the template to deploy from the subsequent build. And so now every time the build and test process completes successfully, it will then kick off a release to push those bits into production. Okay? So let's see if this has, there we go. Completed. And I will save and click OK. And so now if I go over here, make that change there, and push those changes, we'll now kick off a build. The build will succeed, which will then kick off a release deployment. Okay? Now you might be saying, now Ryan, that's a lovely demo, but in my world, we don't just automatically deploy everything to production with no people involved. You can set up pre-approval steps as well as post-approval steps throughout this workload. So if you need approvals to create builds, you can add those steps, or if you need approvals for releases, you can add those steps as well. Okay? So the cool thing is we just automated our deployment pipeline all the way from code into production. Now there's one other thing that's kind of interesting here that I don't think I touched on. This also allows us to separate the permissions of the people who are able to deploy things from the people who are able to make code changes. So the thing is, that service principal that VSTS created for us is the context that is being used to deploy these applications. That is separate from the context of the user that's checking the changes into source control. Okay? So let's go back to our PowerPoint. There won't be too many slides today. I'm sure you guys are very disappointed. Wednesday afternoon, about halfway through. So the next question, as we joked earlier, we've all made the mistake of checking some sort of secret or credential or password, so on and so forth, into source control. And so the thing is, this is a big problem, a big issue, especially as we try to push people to treat their configuration as code. And so what we've done is we've integrated Key Vault with Resource Manager. How many of you have used Key Vault before? Okay, so a few of you, I hope that maybe if we do this demo a year from now, every hand will go up in the room. So I'll show you guys how to do this. What we're able to do is you're able to allow one particular user or set of users to place secrets into a Key Vault. Now, the ability to write to these secrets, delete these secrets, update these secrets, or read the secret is independent from the ability or the permission to read the secret. And so what this means is in your templates, you can point to your secrets via reference rather than providing them by value. Okay? So let's take a look at that. So go up a level and so I've pulled up here, nope, here, good. Our code, and I'm going to kick off our script because it can take a couple minutes to run because it's going to deploy a VM in the background, and then we'll talk about what's happening. I don't trust that. We'll talk about what's going on in the script while it runs in the background. Sorry, hold on. Okay, so in our script here, we gathered, as you saw, I entered a password to place into the Key Vault. We create a resource group. We then create a Key Vault. For demo purposes, it's actually commented out at the moment because we run these demos over and over again, prepping. We then place the secret into the Key Vault. I then echo the vault ID and the name of the vault secret to the prompt. And then I create a template deployment using this template link and this template parameter link. Okay, so pretty standard deployment script, only we place secrets. We created a key vault and placed secrets in the key vault ahead of time. Now, let's look at our template. And so you'll see our template looks pretty standard. We get information like admin username, admin password, DNS label prefix, OS version, variables. And then when we look at the resources that are being created, this is going to look very much like every basic virtual machine that you've deployed with templates prior to today. So there's a storage account, there's a public IP address, there's a virtual network, there's a subnet, there is a NIC, and there is a VM. But what's really different here is how we provide the parameters to this template. And so I'll pull up my parameters file, and what you'll see here is I provided an admin username by value. I provided my Windows OS version by value. But when we look at my admin password, we'll see here there's a reference to this particular key vault ID. And so what happens is during template execution, ARM reaches out to the key vault, retrieves the key, and then uses it as a secure string through the process of deployment, okay? And so I was able to deploy this using a password. I guess in this case, I typed in the password, so I know what it is, but the template itself had no knowledge of the password that was used to deploy that VM. And so if we go back to our script, we'll see that our deployment completed, and we now have a virtual machine up and running using the secret that came out of Key Vault. So the next thing that we think about is, okay, so I've been able to solve the problem of people making mistakes when they try to deploy my templates. We've been able to secure the templates that they're deploying by keeping secrets out of them, by keeping them in Key Vault, and also separation of concerns. One person can put secrets into the Key Vault while another person can use them in deployment. But what if I could enforce compliance? Tell you a little story. I was telling you earlier, I'm actually on parental leave right now. We have a really cute, almost one-year-old girl, and so I wanted to hang out with her and spend a bit of time with her. But my oldest daughter got very, very sick, had a stomach virus, and we had to take her to urgent care. And I sat down, and we were talking to the doctor, and he pulls up, an EMR program on his laptop, or it was more on a cart. But anyway. This medical data has very strict rules that it has to remain within a particular geography. And so we see these sorts of scenarios all the time. How do I keep my applications infrastructure, my app topology within a particular geography? How do I ensure that resources are appropriately tagged so that I can charge different groups within my organization for the services or resources that they're consuming? How can I restrict from the set of services that people consume in Azure? Or if I want to enforce a naming convention for resources, how could I do that? And we're able to do this with a feature or capability we call resource policies. Resource policies allow you to restrict the acceptable set of goal states for resources. Now, there are a couple key concepts that we should talk about. Policies are a default allow system. So you define your policy violations that will be denied, audited, or appended and remediated. These policies are described via a policy definition, and they are applied at differing scopes via policy assignments. So if you've worked with RBAC, or role-based access control, where you have role definitions as well as role assignments, many of the concepts will be very, very similar, with the exception that role-based access control is a default deny system, while policies are a default allow system. And so when we look at the policy definition language structure, it's actually kind of simple. If, and then a given condition or set of conditions or logical operators, then, and we follow it with an effect, which is either deny the request, audit the request and flag it as a violation, or append and auto-remediate the request. Within the policy definition language, we have three logical operators. We have not, and, as well as or. And then we have a set of conditions, or I guess you could call these just operators, equals, like, contains, in, or contains key, okay? And then we have a fairly broad set of facets that can be governed via policy today. So across all resource types, you can govern name, type, location, tags, tag values, as well as resource kind. And then we have a very, very broad set of resource provider or resource type specific facets. The ones that we see used most commonly are virtual machine size. This is excellent for COGS control. If you have a bunch of developers that are using test environments, but you don't want them to deploy Godzilla SKU for Hello World, it's a very helpful tool there, or also ensuring that you meet minimum SLAs. So if you don't want anything to run on instance sizes smaller than an A4, then you can prevent that via policy. The other thing that we see that is quite frequent is people will have policies around virtual machine images where they say, hey, I only want to use let's say you're a shop that does Linux, you have a preferred Linux distro of choice, and you don't, let's say you like Red Hat or you like SUSE, and you want people to only use those preferred distros, you can restrict those through resource policy as well. And we're adding these constantly. We add one of these, two of these a week, okay? And so let's create a location policy. Okay, so we'll pull up the code, and then while it runs in the background, we will look at it. So the first thing that we do is we create a policy definition. And so this policy says if the location is not in this list right here, then deny. And so you'll see the list of 1, 2, 3, 4, 5, 6, 7. Am I counting correctly? No, 8 US regions that we have today. Hopefully we haven't added any since I wrote this script. It seems like we add a new region every other couple of weeks. So I say, hey, if it's not in that set of regions, then deny the request. I then specify the scope to which I want to assign this particular policy. And so in this case, I'm applying the policy at subscription scope. Now note that you can apply these policies at any scope. So subscription scope, resource group scope, or individual resource scope. And then I create that policy assignment, and then using that definition, and I then try to create a resource which violates that policy. So I try to create a website in West Europe. And so if we go over here to my script, you'll see we created the assignment as expected. And hey, I get this red. It's kind of funny because normally in demos, if you see red as a presenter, you freak out. In this case, the red is actually a good thing because you'll see right here, the resource action right here is disallowed by one or more policies, and then we provide the ID of the policy which blocked the creation of this non-compliant resource, okay? So a very, very powerful tool. A lot of people ask, well, what do policies typically look like? We see lots of people creating policies which govern tags. We see lots of geofencing policies. Those are the two most common. We also see ring fencing, or I'm sorry, not ring fencing, service curation, and the VM size and VM image. Those are probably the top 5 scenarios that we see people using with resource policies today, okay? So. Now, gosh, I'm trying to think how to explain this without maybe sharing too much. Have any of you been working, let's say, to clean up an account or subscription? Let's say maybe your bill was a little bit bigger than you thought it was supposed to be, and so you're going through and you're deleting resource groups or resources, and then all of a sudden your pager starts going off, or Bob in marketing calls and asks why the website's down. I see one hand. I see one honest person in the room. I'm going to put my hand up too. Are there any other honest people in the room? Okay, a couple of honest people in the room. It's okay. We have a support group for the rest of you. We'll help you to be more honest later. So at the end of the day, accidents happen, and resource locks exist to prevent these things from happening. They allow administrators to create policies which prevent accidental changes or deletions. So policies, we have 2 flavors of them. One of them prevent accidental deletion, while the other one prevents changes as well. And so There are three key concepts here. The resource lock, well, we talked about what that was. We have the lock level, which defines the type of enforcement. We have two kinds, cannot delete and read only. And then we have scope, which is the realm to which the lock level is applied. Similarly to role-based access control and policy, these things can be assigned at subscription, resource group, or resource scope. We aren't too creative, so a lot of our stuff works the same. And let's see it in practice, okay? So I'll pull up my command prompt. Oh, how about this? I will put it up on the screen so you can see my command prompt. And we'll go into resource locks. So we'll pull this up in VS Code, and then we will run the PowerShell script in the background. And so we've got our script up here. The first thing that we do is we create a resource group. We then get a random deployment name, and then we create a deployment using this template, using that deployment name. Now let's take a look at what's actually in this template. I have two resources defined. That's a fairly simple template. And there are two things here. The first one is the storage account. This is the asset that in this case we're trying to protect with the lock. Then down below what I have is I actually have the lock resource itself, okay? So this is something that a lot of times we don't talk about. Maybe we should talk more effectively about it. But when you think about things like access control, even so role assignments, when we think about policy, like policy assignments, or when we think about resource locks, these things can also be created through the templates that are deploying the application itself. And so in this case, we're deploying a storage account, and then immediately after that, we're deploying a lock which prevents accidental deletion of that storage account, okay? And so if I go back to our PowerShell script, you'll see that we attempt to delete the storage account. That will fail. We check to see if it exists, and it will. We then remove the lock. We wait a moment, and then we try to delete the storage account, and then we verify that our deletion did in fact occur. And so if we look at the status right here, we created or we executed our template correctly or effectively up here at the top. We then try to delete the storage account. It failed because there's a lock that conflicts. We then check to see if it exists. It does. We remove the lock. We then try to delete the storage account, and then we check to see if it exists, and it doesn't, okay? So those are resource locks in a nutshell. So how many of you have participated on any of the Resource Manager Yammer forums? Okay, not too many of you. Okay, well, I'll talk about some of the things that we talk about on those forums on a regular basis. The most common question I get is, how do I do such and such in a template? And these questions usually fall into two camps. One is, I don't know what property, foo, or bar means on this particular resource provider. And I have to admit, we have in excess of 110 resource providers in production today. I can't remember all of them, and so I typically will connect the person asking the question with the person working on that particular resource provider. But the other class of things questions that we see all the time is, how do I do this particular thing? How do I implement this type of logic in my resource manager template? This has been everything from how do I do nested deployments, how do I implement pseudo conditional or branching constructs in my templates, how do I pick things from a particular set. And so since we chatted last time, we've added a number of new template language expressions. We added length for finding the length of strings, split for splitting strings based on a delimiter into an array of elements, add, subtract, multiply, divide, super handy for various networking scenarios. Oh, I forgot mod, also important. For those math scenarios. We have conversion functions to convert things into string or into an int. We have unique string. This is actually a very, very important function, especially when you're trying to create, like, let's say that you have an application which needs high storage throughput. You need to partition that across multiple storage accounts. Unique string gives you a deterministic way to generate a unique string based on entropy that you provide. And so it's not random. That's very important for us to understand because unique string, every time it operates or executes, gives you the same result based on the same input, okay? So this was actually one of the ways that we dramatically improved deployment success rates of various templates that we have in the gallery today. We have trim, which removes white space. We have URI. This is very, very helpful when you're using nested templates and you need to be able to work with relative paths in URIs. It's very similar to the .NET URI builder functions. Substring, and then take and skip for array manipulation, okay? So with that in mind, I'd like to invite up Telmo to talk a little bit about the work that he's been doing. Telmo actually works in Azure Cat. How many of you have heard about Azure Cat before? So they go out and they work with some of our most demanding customers. Most complex, yeah, we won't say they're demanding. That's not very nice. Yeah. And so these are some of the things that they've learned and packaged for you guys to consume. So Telmo.
Absolutely, thank you, Ryan. So like Ryan said, my name is Telmo Sampaio. I work in Azure Cat. Like he was saying, Cat is the customer advisory team at Microsoft. And what we do is when things are really not going well, large complex environments, we go in and try to help customers. The team within Azure Cat that I work in is a patterns and practices team. If you're developers, you probably have heard of us in the past. We created the enterprise library for .NET back in the days. And now we sit under Azure, also looking at practices and patterns and finding out what are those little things that customers have a hard time with and what can we do to help them be successful and avoid those little pitfalls. Right? And in doing that, there was a few things that we, found out that I'm going to share with you here. And it's interesting, I'm just going to go back one slide here because Ryan had this beautiful list of template expressions and functions. The work that we've done used every single one of those functions are in here. Right? So if you ever need to see how to use them, there's some nice examples on what we did that you're going to find out here. But what we're working on is something called reference architectures. And I'm going to talk a little bit about that. Right? The idea behind those reference architectures was to look at all those problems that we found with customers, figure out how we solved those problems. So those are proven practices now. Right? And package that in the form of what we call golden paths. A golden path basically says, hey, if you're trying to deploy a VM in Azure, here are the things that you must do or that you should do so that you're going to be successful, right? And we also abstract from some things in there that you should not be doing. And then we combine those golden paths together and we create end-to-end scenarios. I'm going to show you some of those scenarios in here. And when we do that, we also want to have some artifacts for our customers to deploy those scenarios so that they can test it out. And what a way of doing that than templates, right? So that's basically what we're using for that. Here's a nice little list of all the reference architectures we have out there today. The idea is that we try to take the customer into a little story where we start by saying, hey, this is how you deploy a single VM in Azure. Here's some of the limitations that you're going to have. Here's some of the best practices. And then we move on and we say, okay, you're probably never going to really do that in production unless for very, very small workloads or testing. So now let's see how you do a workload that will be spread across multiple VMs with a load balancer. Then we say, hey, that's also great, but you might have multi-tiered applications. Here's how we do a multi-tiered app in Azure. Oh, awesome, but now we're in one region. If that region fails, what happens to your application? So here's how you distribute that across multiple regions. So we take you in that little journey. And after that, we go into connectivity, connecting to on-prem. We go into identity, right? And when we started developing this, and I will show you what some of those look like, right? We found out some patterns. So I'll give you an example of some of the architectures that I mentioned. This is the multi-tier app layout. So you can see here I have a 3-tier application. One of my tiers, which is the data tier, has a couple of VMs. The other ones have VMs behind load balancers. Notice that the middle tier in there has an internal load balancer. The presentation tier has a public load balancer. I have a jump box down there, and it's a different subnet. This is one of the basic ones that we have. and say, hey, I want to connect this to on-prem. So here's another example, another reference architecture that we did. And there are about 12 of those. Here's the most complex that we have right now on a single region, where we now have multiple workloads. We have what we're calling DMZs here between on-prem and Azure, between the internet and Azure. And when we started looking at this, we identified a few things. There are some places where all I need is a couple of VMs, right? So they're working by themselves. They're not sharing any kind of workload. There are other moments where I need those VMs to host the same workload and work behind a load balancer, whether it's public or private, internal, better say. There are moments where I need to connect to something. So I need a gateway of some sort and a connection. There are moments when I need a DMZ between two different areas. So we looked at this and we said, hey, we are just doing the same thing over and over and over again. What a great case to use nested templates. So what we developed were some nested templates that become a little bit complex because of a lot of choices that we have to make that will deploy those specific blocks. So we have a nested template in there that's going to deploy multiple VMs behind a load balancer. I call it and say, I need 10 VMs. It's an internal load balancer. Here's the subnet. Here's the IP address. Go do it. And we can use that in every single one of our reference architectures that requires that specific construct. We did the same thing for DMZs, et cetera. And it's all based on ARM templates. Here's an example of that, right? We are looking at the most basic one, a VM block that will allow you to create as many VMs as you want. It follows the recommendations that we have in the guidance that we talk about, and here's some. We're saying that for production, you should always use premium storage. We're telling customers, hey, you can use standard storage, but that's for logging. You should always have logging. You should not have more than 20 VMs per storage account. And if you're creating multiple VMs or sharing the same workload, they should be spread out into different storage accounts. So some of that guidance is not just in a document, it's actually implemented in those nested templates. There are things that you can just not do, right? And we have those templates and we expose to customers a parameter file that they use. And yeah, there's a lot of things in here that are similar to what you've seen for virtual machines. There's a lot of settings in there, but look at the bottom where we have the building block settings, right? That's where I go in and I say, hey, I'm gonna create 4 storage accounts. I'm going to create 10 VMs. And somewhere in my VM up there, you see that name prefix, app1. I have that start index at the bottom. So the first one is going to be app1-1 and -2, 3, 4, 5, etc. Some of the things that that template's going to do is it's going to divide or spread those VMs across the 4 storage accounts. If you do a 10 divided by 4, that's 2. There's 2 left. So there are 2 accounts with 3 VMs, 2 accounts with 2. All of that is done in the background for you. Right? And it's all using nested templates and all those functions that Ryan showed. Another thing we do in our reference architecture documentation is we give you not only that template to deploy, but we give you scripts to deploy that both in PowerShell and Bash. So if you're running Linux, you can still use this without changing anything. Right? We want to make sure that all customers are able to use that. So that's the work that we're doing, using nested templates and all the great stuff that Ryan's team builds for us. We keep pushing for more, right? And we'll keep pushing. And with that, Ryan, I think I'll bring you back. Thank you, guys.
Excellent. Thanks so much, Tomo.
Hey, no problem.
I appreciate it. It's really cool to see. You know, we do engage with customers constantly through Yammer, through the forums, through user voice, through other mechanisms. But it really is cool to see the ingenuity and the things that other teams are able to build, both inside of Microsoft as well as outside of Microsoft, based on top of the lower level primitives that we have in Resource Manager today, like all of the disk partitioning stuff using div and mod. It's like, oh my gosh, somebody actually used that the way we thought they would. And, so it's really neat to see those sorts of things. So, oh, that first link is wrong. I will fix that right afterwards, right after this session. But a reminder, all of the content that we're talking about today is available on GitHub, so you can try it as soon as you get home. We talk about how to create service principals, so accounts for automatic deployment of applications in the article linked there. We have a great overview of Resource Manager policy, as well as Visual Studio Team Services plus ARM integration that we demoed during our continuous integration and deployment demos earlier. We talk about template deployments at the link provided there, Key Vault integration with the secret storage below that, audit logs and deployment operations below that, and then locks there at the end. There's one other thing I'd like to show you guys, just because we switched earlier since it was taking a little bit longer than expected. I want to show you that, hey, this demo did in fact work. So if I go to my release right here, we can see that it did in fact deploy. And so if I select this right here and then view this particular release, we will see that this particular item did in fact deploy successfully. So hey, it's not smoke and mirrors. We just did a little bit of an optimization for time. In fact, we might have over-optimized for time a little bit because we're done a little bit earlier than expected. So we can do some choose your own adventure where you make me do demos that I haven't prepared for. We can do questions and answers, or we can do a hybrid thereof. So questions? Yes, this gentleman back here. So you're saying using tags, you want a policy that will append tags? Did I hear that correctly?
Yeah, so basically, this is a scenario that one tag says you must put it into cost center, right? And another tag says you must do a few things. And I will try to tag for dev resource. Nothing, I will try one tag for cost center.
So where one tag could trigger other tags to be added?
No, basically, I won't be able to add multiple tags to the policy just to do it.
Okay, you want a policy that adds multiple tags? Okay, if I've still missed it, then I tell you what, let's either use the microphone because it's a little hard to hear you, or maybe we should take your question offline and yeah, let me answer somebody else and then we'll take your question. Yes, sir.
Where did it go?
Where did it go?
Where did the binary go?
So,
It's not a silly question, it's kind of important. I'd like to use this stuff, but I have to deploy a lot of things.
yes.
Just on a basic level, we use, we have the dev, we got staging, we have pre-production, we have production.
Yes. So the question is, where did the build or the artifact go? And so the build output right here is placed in it's like the Visual Studio Online variant of a build share. It's accessible by VSTS. It's not visible to other properties very easily. And so there's actually an additional step which allows you to copy those assets to another location. And so the most common pattern in practice that we see there is people will copy those assets to blob storage in Azure, protect them via SaaS, and then deploy from effectively a build share that's hosted on Azure storage. Did I answer your question?
Okay. How is that, what's the advantage of, right now I copy files, so maybe might call it a shared, super like a web site. Now they're all, got a farm pulling from a share on Southern Caribbean. Right? So what's the advantages, not just copying them through the environment, I see some of that, but this last part kind of loses me on.
Yeah, so the question is, what's the benefit of using this versus just copying those assets myself or leveraging shared content and config in a web farm?
Because it sounds like I'm ending up doing the same thing at the very end.
So the result may end up looking the same. However, what's different here is you have an automated workflow with checkpoints along the way where you can build, test the build, publish, and then validate against those published assets rather than a more manual process where the binaries are placed directly on the machines. We do have a more advanced scenario where we leverage a template that defines a set of virtual machines and then leverages DSC to suck in guest configuration and deploys a web package on each machine. The benefit of that scenario compared to a typical shared content, shared config IIS deployment, of course, is it's effectively shared nothing. So when you use shared content and shared config in IIS, you of course are subject to the availability of the underlying file share. So in many cases, the outcome is similar or the same, but there are nuanced differences. But the biggest benefit, I would say, is automated workflow with checkpoint and testing along the way. Did I answer your question? Yeah. Okay. Yes, sir. At the microphone.
Hi. You showed us an example of Hello World for continuous deployment. Is there maybe a 2-minute demo that you could provide, or at least some reference that shows how infrastructure as a code is built through the ARM template and it's slightly more complex than a Hello World?
So I can show you the template that could do these sorts of things. It takes a little bit more time to specify the parameters, which is actually why I don't do that demo here. But let's see. In fact, this is good for us to talk about. I'm going to go here. I'm going to go to GitHub. I'm going to go to Azure. And then I'm going to go to Quick Start Templates. And so how many of you guys have seen this GitHub repository before? Okay, so a number of you. So there are, oh my goodness, more, oh wow, they refactored it. It's actually a bit smaller than it used to be. But lots and lots, oh wait, hold on, I'm sorry, I clicked on the wrong one. This is Azure Stack. Man, okay, let's try again. So this is the library of Quick Start templates. I mean, there are hundreds of these things. And they range everything from how do I push a particular DSC configuration into a VM to how do I do that with Chef or Puppet, DSC, how do I use PaaS services like web, SQL, cache, so on and so forth, all the way to how do I run, a 20+ node Elasticsearch cluster, deploying that infrastructure as well as that in-guest configuration as code. Okay, so lots and lots of examples here. Now, the question is, okay, well, you said setting up the demo was a little bit more complex. Why didn't you just do one of those? Really, the only difference is, well, there are two differences. One is the more complex templates oftentimes use a series of nested deployments, and so I would need to publish all of those templates as a part of my deployment and build the paths appropriately. And the other thing is the more complex templates accept a larger set of parameters, and so it takes a little bit more time to provide a parameters file or using the VSTS syntax, provide all of the different parameters as inputs to the template. But all the concepts that we showed are the exact same. I'm looking. It's not. If you go to github.com/Azure and search for Quick Start, you'll find it. And just make sure you don't do the goofy thing that I did and click on Azure Stack instead of Azure. Did I answer your question? Excellent. Next question. Yes, sir.
So the environment creation is part of the release definition.
The question was the environment creation is a part of the release definition. That was your question?
Yeah, and then I guess what I'm getting at is if I only want to create that once and then just look at releases over and over, what's the best practice for handling? I only really need to create the environment once.
Yes. Yes, so the question was, hey, I really only want to create my environment once. What's the best practices for quick deployments of bits without messing with topology? So there are actually two schools of thought on how to do this. And even within Microsoft, we see different teams use or leverage slightly different approaches. So one approach is, and this is for what I would call the hardcore, like declarative goal-seeking folks among us, where they want their configuration completely represented in code. They literally have one template, and they just run it over and over and over again. The thing is, these templates are idempotent, and so when we see that you've declared a virtual machine, if that virtual machine already exists, it gets treated as an update. In many cases, those updates are no ops, And so the template just continues executing, okay? So that's option one, is monolithic template with both config and code in the same thing. Option number two is we'll see people where they have, they use an outer template with two nested templates. The nested templates, template one defines the environment, template two defines the in-guest configuration for that environment. And so if they want to deploy everything at once, they can deploy the outer template, which kicks off the two, or if they just want to deploy the in-guest config, they can deploy the inner template. So you might be asking what the benefit is between the two approaches. Pushing just the config in the guest is a little bit faster, while the monolithic or the more monolithic approach decreases the probability of configuration drift. Did I answer your question? Okay, excellent. Any other questions? And I'm sorry if I'm missing folks in the back. I kind of get blinded by the lights. Yes, sir.
A similar question in the order of this as well with the security settings related to scripts. Maybe one out the keyboard, are you better off having a separate template set up that is only run the first time as regards to configuring keyboard or putting that keyboard value, so principles and so on?
Okay, so the question was similarly to the question earlier, when you have in-guest configuration that requires secrets, what's the best practice for factoring those things out appropriately? So you can use the exact same pattern that we used with Key Vault for the VM password for the secure settings that are used by the in-guest agents or in-guest extensions. And so that would be our recommendation. Whether you choose to use monolithic template or decomposed template is really up to you. We do see a lot of people, as their applications scale, they do factor into multiple nested deployments. In fact, almost all of the examples from the patterns and practices team use that. However, they're always orchestrated by a big outer template that orchestrates across the smaller templates. But everything we walked through earlier with Key Vault, those same concepts apply to sensitive in-guest configuration.
When you're doing the deployment from the STS, ARM runs under the service principal that's configured to connect, so that service principal then has to be set up to keyboard to allow access to those.
So the question is, when we're doing these automated deployments, what are the permissions or ACLs associated with the secret that allows ARM to retrieve them? What happens is when we created the Key Vault, there was a switch there that said enable for deployment. What that does is that allows ARM, the service, to be able to retrieve those secrets at deployment time. They're retrieved in a way where, unless you're really trying, they won't get sent back to the user, so they're kept securely in the vault, but it is under the context of an ARM user, not the service principal, that those secrets are retrieved.
And if I use a key that a different subscription might have, would ARM be able to pull that back out?
So the question is, if I knew the ID of a key in a vault in a different subscription, would you be able to retrieve it? So ARM performs a linked access check to confirm that the user that is running the deployment has permissions to the key. In this case, the service principal has permissions to it, so we permit ARM to use its service context to retrieve the secret. But there's actually two answers to your question, depending on how advanced the scenario is. Today, we're able to perform those linked access checks across subscriptions, but within a single AAD tenant. If the subscriptions happen to reside in two AAD tenants, then the answer is no. Under no circumstances would that be allowed to happen, because we do not do cross-tenant authorization today. Okay, did I answer your question? Okay, and hopefully I repeated all of that sufficiently so that everybody was able to follow. At the microphone.
Hey, for policies, are you going to build a user interface or like a policy editing tool where, you know, maybe customers that aren't kind of coding could build policies and deploy them, or view ones that are in
Did I
place?
see a hand raised? Similar question, or were you seconding the feature request? So you guys know that in public forums like this, we usually try not to make statements about roadmaps. However, what I would say is that is a very good idea, and I wish that people at Microsoft had thought about something similarly. As we continue to hear requests for it, we will continue to prioritize that feature request. So we are thinking, I can't say we're doing it, but I can say we're thinking about it. Oh gosh, that got recorded, didn't it? Okay, yes, sir.
Is there a link to the reference architectures that Telmo was showing?
Yes, there is. So in that, in the GitHub repository, items 6 and 7 point to both the building blocks as well as the reference architectures from Telmo.
That's AKANS/architecture.
Yes, sir.
So when you update a resource in your template and push that to build, does it kick out whether it's going to have to delete or modify the existing resource, like what they can have to delete in your environment?
Good question. The question was, when I check in a change to source control, is there a way that I can see or understand whether the resource will be deleted or updated? Effectively, what is the impact of that code change? The way it works today is anything that is declared as a template gets executed as an idempotent put. So in HTTP or API parlance, it's create or update. There is never any case or place where ARM will delete a resource and then recreate it. It is always, at least semantically or from a protocol perspective, articulated between ARM and the resource provider as an idempotent create or update. Okay? Now, there's kind of a nuance to the question that you asked is, let's assume for a moment that a change to a network security group or some other networking thingy, those are usually the ones that are most susceptible to this class of I don't want to say problem, but problem, where when you update this thing, you might lose network connectivity for a period of time while that config change rolls through. We don't really have a way today of expressing the difference between something that is a no downtime implicating change versus a downtime inducing change. However, there are no cases in a regular or incremental template deployment where we would ever destroy a resource. Now, if after working with ARM, you're totally signed up, you get your declarative tattoo on your arm, sorry. We do have what's called a complete deployment mode, where we will execute the template. We will look at the resources that exist in the resource group as well as those that were declared and created or updated via the template, and we will delete any resources that exist that are not defined. That's the only circumstances under which running a template would be destructive from a resource perspective. There are probably some other edge cases where if you tried to update like an encryption key and you did it incorrectly, then it could result in not being able to see that data until you fix the encryption key. But those are very edge casey resource provider specific things. So did I answer your question? Okay, hopefully I didn't over answer. Okay, let me check here. Okay, any other questions? No? Okay. Well, I've, I guess, bored you all. Thank you so much for your time today. Enjoy the rest of Ignite, and if you have any questions about what me or Tomo talked about today, we'll be here for several minutes afterwards. Please come on up and ask us, or if when you get home you have a question, feel free to ping me on Twitter, RJMax. I'll be back October 24th, or email me, ryjones@microsoft.com. And I'll be more than happy to help you. Thank you so much for your time and have a good afternoon.